All right, so notes for the kitchen sink. I've already gone through the warm-up on the difference quotient, so you can look through that if you just started the video and pause it and see if you did that correctly. And so I used to not give notes for this kitchen sink worksheet that's coming up. It was the kitchen sink worksheet. It really starts to review many of the things that you've had so far in this unit. But I found that I kept on answering the same questions every year, so I thought, well, why not do some notes? It might help people out. So that's why these are here. So this is meant, it's some review with just a couple of new twists in here. You've had such notation as f of 2 before. That means when x is 2, what is y? But oftentimes you have an equation that you plug 2 into, but you don't here. All you have is a graph. So you need to go where x is 2 and note what is the y coordinate, what is the height when x is 2, and that is the answer. I have students who get stuck on the quizzes and they go, what does this mean? But it's been in homework. Don't let that be you. The turning points, the turning points are here and here. It's where it changes from increasing to decreasing and vice versa. Those are my turning points. And so they are ordered pairs, XY ordered pairs. And so this is at -4 and up at 6. You need parentheses, -4, comma 6. That's an XY ordered pair because it's talking about a point. And for points, we just put commas between. We don't do union symbols. We use the union symbols on intervals where it's increasing, decreasing, positive, negative. For ordered XY pairs, we're just going to put a comma. So then we have a turning point right here, which is at 2, -3. And that's it. Those are my two turning points. On number 3, if you got rid of this, that f of 6 looks a lot like f of 2. And you calculate it just like you did f of 2. You go to where x is 6. 1, 2. And the y coordinate there is 2. So the value of this is 2. And the dot indicates multiplication. So I would like to see below this that you're taking 3 times 2. So that I know what the value is that you use for f of 6. And your final result is 6. Average rate of change on this interval. These are both x values. This is x sub 1, this is x sub 2. It's from your homework last night. And so I want to see your two ordered pairs. You have when x is -4, you're going to have to find y. When x is 6, you need to find y. I want the ordered pairs listed that you're using. Average rate of change, you find 2 ordered pairs, you find slope. And so at -4, you are up at this point, and at 6, you're at this point, and what you are doing is you are finding the slope of the line that goes through those 2 points. That's known as the secant line. So at -4, you're up at 6, and at 6, you're up at 2. There isn't a function listed, so you have to use the graph to get the y value. You have to use the graph. And then I want m equals for communication. You're finding the slope. Change in y, right? 2 minus 6 over change in x. 6 minus a -4 is 6 plus 4. And you get a -4 over 10 and simplify. And you have a -2/5. And the next one brings in absolute value, which is new. In these types of problems, we haven't had it before. These bars at the start and at the end are absolute value. Now, you need to calculate and simplify everything inside, get it to a numerical value, then take the absolute value. I've had people who get a few numbers in there and then they just make them all positive. That's not how it works. You got to treat it as parentheses and simplify inside first. So this is 4 times, and when x is 2, y is -3. F of 2 is -3. and then minus 2, f of negative 4 is 6. And we have our absolute value. So simplify inside, you have a minus 12 minus 12. You need to combine that to make it absolute value of negative 24, which is 24. For the x-intercepts, it is the x values where this crosses the x-axis. You can list them as ordered pairs or just single values. And you're just estimating when it's in between. So 1, 2, 3, 4, 5, 6, 7. So I would say it's a negative 7.5. And the next one's at negative 1.5. And over here, that's to the right at 5. And this f of x in number 7 being greater than 0 is just a fancy way of saying what are the intervals where f is positive. In number 8, f of x being less than 0, it's just a fancy way of saying where is it negative. So positive and negative intervals. And when you are using positive and negative intervals, you are using endpoints and x-intercepts for your boundaries, for your key points. And I like to put a number line underneath the graph. And so we're going to mark boundaries. This is at negative 8. Then we have negative 7.5 is an x-intercept. And at negative 1.5 is an x-intercept. And at 5 is an x-intercept. And you stop at 6. So you use the starting point, your ending point, and every x-intercept. In this first short little interval, the function is below. And so in that interval, it's negative. And I'm just going to put a negative symbol there because that's just shorter than writing positive and negative. And then on the next interval from intercept to intercept, the function's above, so the function is positive on that interval. Then it goes below, and then it goes above from when x is 5 to 6. So where are the intervals where it's positive? Well, you use parentheses at the x-intercepts. Because at those two x-intercepts, the function is not above or below. It is not positive. It is not negative. And we use union symbols on the intervals. And it's positive again on the interval from 5 to 6. Now, at 5, it's an x-intercept. It is not positive or negative there, so we're going to have a parenthesis on 5. However, on 6, at that point, it is solid, and for that x value, the function is above the x-axis. This is one of those tricky points that I put on tests and quizzes. Why didn't we do it on negative 8? Oh, we haven't gotten, because that's on the interval where it's negative. So we'll do that on the next one. Sorry, but here at 6, the function is above and that it does exist. All right, so intervals where it's negative they are going to be parenthesis and negative 8 to negative 7.5. They are both parentheses because at negative 8, the point doesn't exist. It's not a value in the domain. So we can't include it. And then union, negative 1.525. And those are both x-intercepts. We can't include those for positive or negative intervals. For the max value, and this is implying the absolute max. It didn't say relative max, relative min. It said max value. The max value is the height, the highest height it gets to. They don't have to have a max. It might not exist. In this case, we do have a highest point overall. There's no arrows to indicate that that's going to keep going and take over and get higher. This is your max. The y-coordinate there is your max value, and the y-coordinate there is -6. This is the highest point for the entire function, so it has a max value. For the next one, min value it's not applicable. DNE does not exist. And it's not supposed to be -6. I don't know why I wrote -6. Thank you for the correction. Sorry, number 9, the height is 6. I have no idea where -6 came in my head. I have no idea. Thank you for the correction. Good save. Thank you. All right, so number 10, this is not the lowest spot. It starts going down and approaches a negative value of -4. But this is interesting. From -3 to -4, there's an infinite number of points. And if I say the lowest point is -3.8 as the absolute minimum value, you could go, oh no, I know another one lower than that, -3.9. I go, okay, yeah. Oh, but I know another point lower than that, -3.99. And we can go back and forth and volley and forever and ever. There's always going to be some point before you hit -4 between what you state and -4. So there isn't an absolute minimum value because of that. So D and E does not exist or not applicable either way. I've been doing a lot of NAs, I think, on the homework assignments. So there we go. All right, then we have increasing and decreasing intervals. And for increasing and decreasing, you use relative max and mins, or absolute as well. Relative max and min, the x-coordinates, as well as endpoints. So I typically draw a different line than the positive and negative, but we do start at -8, and we do end at 6, starting and ending points. But now it is the turning points, the x-coordinates of the turning points that you need to use for your boundaries or for your key numbers. And the x values of those turning points are -4 and 2. Now, you always need to drive your car from left to right, trace from left to right. You're going up, 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 up in this interval. So that is an increasing interval. And after that turning point, you're going down, down, down. So that is going to be a decreasing interval. And then you end with an increasing interval. So for your increasing intervals, the -8 has to, excuse me, the -8 needs to be a parenthesis because it's not in the domain. And then it goes to -4, and this is the change this year. We are including that. I'm trying to make sure that the worksheets are getting corrections as we're moving along so they reflect the change. And then we use union symbol. And then we have 2 to 6 defined at each of those points. And so they both will have brackets. And your decreasing interval, -4 to 2. And your domain, you start from -8 and you go all the way to where x is 6, and that point is included, so we need to include that. And for the range, you're at -4, but that's going to be open, and it goes as high as +6, Mrs. Remington. And it's in between there, so the range is -4 to 6. -4 is not included, the 6 is. All right, and you have 2 parts to your assignment, the next 2 worksheets. You've got review of the difference quotient, extra practice on it, and then you've got the kitchen sink worksheet, which kind of has a lot of stuff going on it, and you will see things like that on assessment.